Chapter 1, Section 2 goes over exponents, roots, and powers of 10. So I first want to go over how to rewrite something that will contain an exponent and what that means as far as how to evaluate and really kind of the reasoning behind how we write things with exponents. So if we have something that looks like this, 4 times 4 times 4, we can rewrite that using an exponent. So we can have 4 raised to the third power. And so the 4 is called the base. And that's the repeated factor. So that's the piece that you're taking times itself. The 3 is called the exponent. And that indicates the number of times that the factor is used in the multiplication. So when I see that 3, that means that I took 4 times itself 3 times. So this expression, 4 to the third, is written in what we call exponential notation, and it has a value of 64. The number 64 is written in standard notation, so that's like what you get when you actually plug it into your calculator and evaluate, or if you actually just take 4 times 4 times 4. Both the exponential and standard notation are called the power. So 4 to the third, if I actually evaluate that, the power of that would be 64 is what we would be saying. Now, 2 of our exponents have special names. So if you had something that said 4 squared, that would look like that, and 4 cubed would have a 3. Anything bigger than 3 as an exponent doesn't really have a name for it. We don't call something raised to the 4th power something special. So anything over 3, so 4, 5, 6, and so on, those are all going to just be like spoken as it's raised to a power of 5 or to the exponent of 5. So what I want us to do first here is identify what the base and the exponent of the expressions would be, and then write them out in standard notation. So for this first one, I have 5 to the third power. So my base would be 5. My exponent would be the 3. And then standard notation would be if I actually evaluated that, and I would get 125. So for the second one, 1.5 to the fifth or to the second power, my base would be 1.5, my exponent would be 2, and standard notation would end up being 2.25. A number that has an exponent of 1 is just going to be the number itself. So if you have a raised to the first power, that's just going to be equal to a. That also works the same way with numbers. So you can see how I have 8 to the first power is equal to 8, and then 2.3 to the first power is equal to 2.3. Anything raised to the first power is just always going to be that self. If you think about any math problem that you've ever seen, if you've got a letter sitting by itself, we don't have all these little ones everywhere because it would just make things really messy. So all those letters technically have a 1, but we don't write them because it would just be itself. So it's kind of like an unnecessary thing. Now we do have something called a square or a perfect square, and this is the result of using a natural number as a factor twice. So a natural number, remember, would be numbers 0, 1, 2, 3, 4, and so on. And so if you actually square those, you're going to get another whole number, and those are called perfect squares. So like 2 squared is 4, so 4 is considered a perfect square. So if I want to just find the square, that would be the same thing as for this taking 2 to the exponent 2, which would be 4. 7 squared would be 49. And 3.2 squared is going to be 10.24. So you're just taking that number times itself. So getting into perfect squares, we have those square root functions, and another word for that is called the radical sign. and that's what that looks like. So it's a little bit like a division sign, but it almost has like this little tail off of the front of it. And so that indicates that the square root is to be taken of the number under the bar. And the number under the bar has a special name, and it's called the radicand. So the entire expression is called a radical expression. So if I look at this example here, I have the square root of 25 equals 5. So the 25 is known as the radicand, because that's underneath the square root. The square root sign then would be called the radical sign. And then that 5, this is what we call the principal square root. So to kind of understand what the principal square root would be, numbers that are being square rooted have two possible answers. So the square root of 25, you could have it be 5 or you could have it be negative 5. Because negative 5 times negative 5 would also get you 25, just like 5 times 5 does. So in this case, because we have 5 written out, that's usually the one that we think of more often than not when we're talking about square roots. A lot of times if you square root something, you just give the positive answer. You don't really always think about the negative one. So the principal square root is kind of the most often thought of answer in this case. So another example here, the square root of 256 would be 16. Okay, this next piece here is starting to get into powers of 10. So powers of 10 are numbers whose only non-zero digit is a 1. So 10, 100, 1,000, those kind of numbers would be considered powers of 10. So I want us to compare the number of zeros in standard notation with the exponent in exponential notation. So if we think about 1 million, what that looks like as a number, if you actually wrote it out, you'd have a 1, and then you'd have 6 zeros. Okay, so it looks like that. So to write it with exponential form, we would have 10 to the 6th power. If we think about 100,000, you would have a 1 and then 5 zeros. So you would have 10 to the 5th power. 10,000 would be 4 zeros. So we have 10 to the 4th power. So I hope you're noticing a pattern here. 1 million had 6 zeros, so that would be the same thing as 10 to the 6th power. So the exponent 6 matches the number of zeros that this number had. 100,000 had 5 zeros, so the exponent is 10 to the 5th. And then the pattern just continues. So 1,000, since it has 3 zeros, that would mean you have 10 to the 3rd power. 100 has 2 zeros, so that would be 10 squared. 10 would be 10 to the 1st power, and 1 would be 10 to the 0 power. So remember that this rule here, anything raised to the 1st power is always itself, okay, and anything raised to the 0 power is always going to be 1. So those kind of relationships will always exist for all numbers. So if we want to look at some examples and express them as powers of 10, all you need to do is write a 10 and then count the number of zeros that you see. So for this first one, we should see 7 zeros. For number 2, there are 8 zeros. And for number 3, there are 11 zeros. Now for multiplying with powers of 10, or even dividing, it makes it really easy because all you have to do is think about moving the decimal place to the left or to the right. Now, if you're multiplying by a power of 10, so multiplying by 10, 100, 1,000, and so on, you just basically count the number of zeros that your number has, your power of 10, and you add that number of zeros to your answer. So when I take 237 and I'm taking it times 100, think about the decimal here is sitting on the end of 7. You move it to the right 2 times. And then you fill in with zeros. So like I said, you add 2 zeros. So your answer here is 23,700. Same thing works with the second one. Now this one has a decimal already for us in there. The 1,000 has 3 zeros, so we go to the right 1, 2, 3 times. Fill in those empty spaces with zeros. So we have 36,200. For this next example, it's saying that if 100 pounds of floor cleaner costs $63, what is the cost of 1 pound? So to find the amount per pound, we're going to take that $63 and divide by 100. Now since we're dividing, the decimal is next to the 3, we want to go to the left 2 spaces and move that decimal. So this answer is going to be 63 cents per pound. Okay, for these last couple, they want us to just use a calculator to help us evaluate. So if you type into your calculator 35 squared, you should get 1,225. 2.3 to the 5th power, if we round it, would be 64.4. And the square root of 529 would be 23. Sometimes with our perfect or our square roots, we don't get nice whole numbers because not every number is going to be a perfect square. So for this one, we want to square root this and round it to the nearest 10th. So when I do that, I get 3.3. And for number 5, they want us to round to the nearest 100th, so that would be 2 decimal places out. And so we get 2.24.